I'm going to go through this example problem where we use the Gibbs Duhem equation to find the partial molar volume of a species in a binary mixture. In the problem, there's a binary mixture of benzene and cyclohexane at 30 degrees Celsius, and we're given an expression for the partial molar volume of benzene and the density of cyclohexane at 30 degrees Celsius, and we need to find an expression for the partial molar volume of cyclohexane. And to do this, we're going to use the Gibbs Duhem equation. For this binary mixture in the Gibbs Duhem equation, that's going to be the sum of this for I equals 1 and 2 is equal to 0. In the equation we have N1 and N2, but in the partial molar volume of benzene that we're given up here, we only have mole fraction of benzene, so it's going to be more convenient for us to change this N1 to X1 and this N2 to X2 because the total moles of each species are going to be proportional to its mole fraction in a binary mixture. From here, I'm going to divide each side of the equation by dx1. This term, dv bar 1 over dx1, we can solve by taking the derivative with respect to x1 of this equation up here. Now I'm going to plug the derivative we just solved for back into the Gibbs Duhem equation. Since this is a binary mixture and the sum of the mole fractions x1 plus x2 must be equal to 1, x2 is equal to 1 minus x1. We can simplify this further to get rid of the 1 minus x1 in the denominator. To solve for v2 bar, now we can just pull this dx1 over to the right side of the equation and integrate both sides. When you do the integration, you get that v2 bar equals 2.64 times x1 squared plus c, where this constant of integration is the volume of pure cyclohexane. And if you go up to the problem statement, it gave us the density of cyclohexane at 30 degrees Celsius is 0.768 grams per centimeter cubed. So we can convert that to a molar volume, and that'll be the constant of integration. When you convert the initial density to a molar volume, you get that the constant equals 109.44 centimeters cubed per mole. And when you plug that back into the expression we had for V2 bar, you get the final answer of V2 bar equals 2.64 x1 squared plus 109.44 centimeters cubed per mole. I hope you learned something from this video and that it helped you understand how to solve the problem. If you like this video, give it a thumbs up and subscribe, and we'll be posting weekly videos for homework help in Chemie 211 at Purdue University.